Howdy, folks. How's it going? Sorry, I don't know if those audio levels are a little high. I saw it was peaking there at red. But welcome to the stream. I know many of you tuning in today are here for the first time. So big welcome to the AWS Twitch channel. This is a channel where we do a lot of live content, particularly for developers, helping you get up to speed with the latest and greatest services here from AWS. But when we're talking about latest and greatest, the topic of today's discussion, Amazon S3, is certainly not one of the newer ones. It's been around since day one. I'm sure someone will check me on whether it was the official first service or not. But regardless, that certainly does not preclude it from being one of the greatest. So we have a fun show today. Again, this show, Developers Let's Code, it is a show aimed at folks that are looking to get started with cloud computing, where episode by episode we're going to cover each of the fundamental building blocks of applications and what that looks like to do so on Amazon Web Services and products. So as its name implies, or as you may have seen in the registration forms, today we're talking storage, which involves Amazon S3. We'll get into that in just a second, but first, a few housekeeping things. John is already correcting me in chat, saying that SQS, Simple Queuing Service, came out just before S3. I don't know. It's a live show. If I knew the answer, I would definitely have that here, but audience participation is certainly participated, whether you are correcting me when I'm wrong or just providing insight and names when I ask for recommendations. So John correcting me was a great segue into pointing the fact out that I am watching chat the entire time. So I want this to be a little bit more engaging than just, I'm talking at you and you're coming to learn, because let's be honest, you could go to watch a video on demand for that. You could go sign up for, maybe a more conventional type of webinar thing. I want this to be sort of an interactive, casual introduction to Amazon S3 and storage. So we're not going to do this wait till the end and then Nick will do Q&A. I'm going to sort of do that throughout. So please, if you have questions, get those in. A little bit about all the folks in the audience here. John asked where everyone's tuning in from. It seems like we have folks from around the world. We have JCOM from San Francisco, Jacob in Maryland, Grumpy Dana in Sydney, Polymord in New Zealand, another from Sydney, another one from New York. I'm in New York right now, actually. It's why it's dark outside. It's about 9 p.m. here. But we've got folks from India, Halifax. Wow. All right. So we got a global audience today. I will try to keep any of the analogies or any of the jokes as global as possible. But this is really great. So thank you for tuning in, and I hope you get something out of this. Again, please interact in chat. If I see you adding your region in chat, I know that you're signed up. I know you can ask questions. No, I am not tracking your IP address, IAVH3Z. I'm sorry. Busy running a stream right now, unfortunately. But yeah, so we're live here on Twitch at twitch.tv/AWS. So we've got this little handy dandy notepad over here. This is going to be our basic run of show for the day, unless you come up with something better. This was my plan for what we wanted to do today. So again, we're here with Developers Let's Code, new series here. Going to be doing an episode, I believe, once a month, but that cadence may change. Maybe it'll get a little more rapidly paced, one every 2 weeks. We're curious if you have any feedback on that. Episode 1, Amazon S3, probably wondering why we're doing that one first, especially if you haven't used the service before. And it's because, again, we're talking about the fundamental building blocks to build applications. And there is no more important service, I guess. Well, I guess that's up for debate, but if you're building an application, you need to have persistent storage for files and objects. As we'll see in just a moment, Amazon S3 does that very, very well. So there's three main parts to today's sort of segment. Again, we're going to run for about an hour, aiming to finish sort of at the top of the hour, but we started a little late, so we'll see where we get to. First, I want to give you a little bit of the basics of Amazon S3. I want to get through this quickly, but I want to enable you to understand where S3 sort of fits into the pipeline of how you would build applications with it, and the core value propositions of S3. It's very powerful, and a lot of the power of S3 and the value of S3 may not be some of these shiny bells and whistles when it comes to features, but simply being a rock-solid foundation that you can rely on. Concepts like S3's durability that we'll cover will really sort of preach to that sentiment. Next, we want to get hands-on. This is where I want to spend the most of the time in today's broadcast. We want to be able to get into the console. We want to mess around on the CLI and show us using S3 in action. It'll make a little bit more sense of what this looks like. But again, as I've sort of alluded to, S3 helps us manage, store, and retain files and objects. And so, within that realm, there are a large number of workflows that users will go through. But there's a small number of them that I think you'll probably find yourself using most of the time as a developer. So those are the ones I want to focus on today. And on the tail end, as time has gone on, S3, again, one of the older services from AWS, there have been a lot of really nice quality of life improvements to it, both from a developer experience perspective, but also from features that you can now do features you can now work with natively in S3 that you previously would have to build on top of S3. This comes from customer feedback over the many, many years and working together with customers to see how S3 can better serve them. We have Jay Reggie in chat is saying that they like the merch. Thank you. This is a selfless plug. I run another show here called AWS What's Next. We cover some of the launches. So if you like this introductory content, check us out on Fridays. Same channel, same place. Cool. So without further ado, we're about 10 minutes into the broadcast, but I figured we could get started. So I'm going to... Let's see if this works. Cool. So let's... Wham. All right, cool. Magic of production. So we are here on the S3 Getting Started product page. Figured we could walk through this. This is a good exercise for me too, because I don't always get to look sort of from first principles here at the basics of the service. So S3 is storage for the internet. We sort of described this already, but largely before we get into any of this technical mumbo jumbo, I'm going to start with an example. This is something that I don't think you'll all see on stage at a reInvent or at your local meetup. But again, we're doing it live, keeping it exciting. So S3 is a service by which you can create a handful of entities that will make it very easy to manage your files. So if I have to manage files, let's think through this a little bit logically. Well, I need some containers to put those files in, and containers may not be a good word because those have very particular technical meanings in software. But I need places to put those files, and objects, and then there's the files and the objects themselves, and sort of everything in between would be all of the connective tissue and the actions I want to do with those very small, those two core entities. Effectively enough, the main entity in Amazon S3 is what's called a bucket. You create a bucket, and you can then put objects and files into this bucket. And we'll talk about exactly the format and how to do that. But then once you've created your bucket, you can put files into it, and you can start building with that on AWS. And you can treat your bucket as the ending location. And in many ways, it can, especially on the CLI, as we'll see, it can behave almost like an extension of your local file system. And I should be careful in how I say that, because there's other services that behave more specifically like a file system to fit that use case. But largely when we're thinking about S3, I mentioned I would have a fun hands-on demo. Let's pop them back over here. This is a good old handy bucket. We got this right here. My lights are very bright, but I think if I focus it a little bit, you can see we got sorry, it's not AWS S3, it is Amazon S3. So I need to make that correction. But we've got our bucket over here, right? So when we see over here, I know this is probably very small, but I won't reference it too much. We create our bucket. We're going to be able to name this. So I am going to look in chat to see what bucket names you throw out, and I'm going to use one of them when we end up getting to the console to create our bucket. So get that name in. So this here is our bucket, right? And I mentioned before, I've been going back and forth between objects and files. In reality, there are only two things that S3 cares about when it comes to storing data or an object. The first of which is sort of the binary data for whatever is the actual file is, or the object, I guess you could say. And the second is going to be metadata, some things around when it was uploaded, and these are and like the name for it and time it was last modified. These things will be tracked within S3. But largely, if we sort of break that object down, it is at its fundamental root sort of the file itself, and then metadata around it that we can perform some other things like permissioning and so on and so forth around. So I've got a handful of I guess objects you could say here. I've got a little pack of stickers. Toss those in my bucket. got another. Oh, sorry, that was probably really loud into my mic. I'll try to avoid that. I've got this second object, and I can just putting this in. Now I'm holding this a very particular way. You can see here that this bucket down here, it's got a bottom. This actually makes this a bad representation of Amazon S3, because the idea and the value proposition to you as a developer with S3 is that you don't have to think about the scale of this bucket. Imagine this is a bucket that has no bottom. You can continue to put more and more and more objects into it, and there will be no degradation in performance. Imagine if every time I wanted an object, I could just reach right in and get that exact object I want, and it does not matter how many objects are within here. So you're probably thinking, hey, this might sound familiar, Nick. This is, if you've got your algorithms hat on or your, databases hat on, you're probably thinking, this sounds like O of 1 lookup for given objects, and in a way it is. You're essentially querying on the key for the object that you put into there, and then you can then hit that. You can then, with both the bucket name, the proper credentials, and the ID of the object you put into the bucket, you can retrieve that. And no matter how many objects you put into that bucket, the object performance, the transaction performance will not degrade with respect to accessing or updating that object. I'm looking in chat, so I'm getting ripped on a little bit from you all, but I'll take it. It's my fault. It's my analogy. It's a bit of a leaky bucket. We can talk about leakiness on the topic of permissions. Let's extend this a little bit further. Let's imagine this is not a great bucket for a lot of reasons, right? It's got a bottom. S3 does not have any limits on the amount of objects you can put into said bucket. Let's say this is leaky in terms of permissions, right? People can probably see into this bucket. We want to make it so that only the right people can see the objects in this bucket, and so that this isn't an open hand. Let's imagine there's a little sensor here that knows only my hand is allowed to pull objects out of this bucket. A little bit of a magic bucket we've got going on here, but S3 can manage to do that. Now, another thing that is very interesting, and when we think about S3 in this way, it sort of evaporates into the background, but S3 has extremely high durability. I believe, if I haven't lost track, it's 11 nines, so 99.99999 until you get to 11. And if you were to roll your own solution for file storage or object storage in this way, this would be very difficult, and this doesn't happen by accident. There's no magical single line of code that does this. But very quickly, a little bit of a peek under the hood. Imagine I have this one bucket here, and it's got, you can see these two objects inside of it. The way you get that level of durability is that you have replicas of this bucket that exist sort of in the background that you'd never have to interact with. But in scenarios where, let's say, something went haywire and this bucket burst into flames, well, we've got another replica behind it that it can automatically fail over to. But the important thing is that as a user, you never have to worry about managing any of that. The beauty of S3 is that it handles it sort of by default. I'd actually be remiss if I didn't talk about what the S3 acronym stands for. I know a lot of AWS veterans or pros in the audience always like to joke around, if S3 was so good, where is, what happened to S2? What happened to S1? When are we going to get S4? And that, if you ever see that, it's very much a joke. S3 actually stands for Simple Storage Service. And so that's where the three S's come from. It's not the third rendition of Amazon storage. Yeah, we've got a bunch of comedians here in the audience today. Also got some good names getting thrown in there. Get buckets, win games. That's a good one. If things go well and we get to the end on time, maybe I'll take a shot into the bucket from across the room. But that one will remain to be seen. Okay, cool. So we understand a bit about S3. It is a service that helps us to provision these buckets, and then I can put objects into the bucket. I can take objects out of the bucket. And I can do this in a very performant fashion. For anyone who has played Dungeons and Dragons, I know we have a bit of a global audience here. I know it's very popular worldwide, but definitely a bit of a nerdy thing that I've done. Post in chat if you've played, but maybe this reference won't particularly land. But in Dungeons and Dragons, or in any role-playing game, there's always, some sort of storage that you have, like a backpack or a knapsack, and you have a certain amount of things you can put inside of it. In Dungeons and Dragons, there is this concept called the Bag of Holding, and it's kind of like this mystical contraption. It's basically a bag that has this big black hole in it, and the inner contents and the inner space of the bag is like infinitely larger than the actual size of the bag itself. And the more and more I use S3, the more and more, while that sounds very mythical and outlandish, the more I like to lean on that analogy to describe the way S3 works. And imagine every time you reach in that bag, you can pull that object out right away and not worry about all the other contents, which is a big realm of frustration when we're talking about things like databases and trying to perform things like durable transactions and all of that. That starts to become a slightly different realm and a slightly different problem space. I know that today's episode is just called storage, but every single databases alone are sort of an entirely different set of problems. This S3 and today's episode will largely be for long-term file storage or for persisting of a file where you're not trying to lock transactions on it across multiple agents or multiple clients. Cool, so I know we've done this a little bit out of order. I went around, gave the acronym last, and my analogies all along the way. Lack of supervision, wondering what's the sphere of annihilation in the S3 bag of holding metaphor. Well, I don't know if we quite have a sphere of annihilation analogy, but we will showcase recursive object deletion in the bag of holding, or in Amazon S3, and maybe that'll fit, but I'll let you be the judge of that one. Cool. So we are going to get started with S3. Again, recapping what we're about to see very quickly. You're going to set up and log into your AWS account. I'm going to assume that all of you all have done that. There's nothing particularly special about watching me do that. And once you are done creating your AWS account, you will end up landing where we are about to be in just a moment. Next, we're going to create a bucket. So again, this is going to be our good old trusty bucket right here. I'm going to pick a name from chat right now. I like get buckets win games, so we're gonna go with that one. So congrats to Moret or Moret 025. We're gonna go with that one, and then we're gonna start building with AWS. Now we're not gonna build other parts of the application today. We are going to mess around with S3 and walk you through some of the core functionalities for it. But all along the way, I will give some examples of common workflows that you would integrate these methods into. And I'm sure you can think of some as well. So if you do, throw those in chat. Happy to call them out. Cool. So getting my bearings a little bit here. There we go. Cool. Wow, this is Stream Deck's working out pretty well today. Sorry for those that are listening. I gotta take a sip of water. Cool. So again, level setting here a little bit. If you can't see or the text is too small in chat, please just yell at me. I'm happy to readjust it. It's just I don't see exactly what you all see. So cool. We're here in AWS Management Console, or as I like to call it, home base. For anyone who's a developer on AWS, you're probably pretty familiar here. And again, if you're familiar to the channel, today's episode is going to be focused on folks that may not have this experience. So some of this may be very familiar to you, but hopefully even if you're an AWS veteran, you may be able to learn a thing or two. So cool. We're in here. We can search through this treasure trove of different AWS services, but we know what we're looking for today, and that's Amazon S3. So we click on that, and it teleports us. Man, I guess mythology and D&D is going to be the theme today. So you won't see these because these are buckets that I've created in the past for some other projects, and some of them are public, and we'll talk about why that could be a good or a bad thing. It's always should be done deliberately, but we'll cover access patterns and securing those buckets, hopefully making them not leaky. I've got some questions in the chat around whether we're recording this and if you can get a copy. Yes, this episode will be recorded by default, and you can always tune in you could always come to this page and then click on the videos, and it should be available there by default. I believe if you registered for this as well, you'll be able to get a copy of that link emailed to you, but you don't have to wait. As soon as the episode's over, you can view it on demand later. Cool. So we've got a few things here. We have our buckets, batch operations, which we'll get into later, and then access analyzer for S3, quite an advanced feature. But like we said, we want to sort of walk through the basic flow. So we want to create a bucket first. So there's a newer bucket wizard than I know is available in the past. we have to enter a bucket name. We've got a handful of constraints here. One really unique part of S3 when you compare it to some of the other services is that in other services, you often operate in the control plane of a particular AWS region. Now, S3 is kind of unique in that these buckets are always global. And now you don't typically need to think about that too much. It's replicated such that it's still performant, so you can pull that data from local POPs if you put it onto, let's say, if you like cache it globally on a CDN or something. But this means that the bucket name that you choose has to be globally unique. So I'm going to pick the one that I went with before, get buckets, win games, but this has to be globally unique. So we'll probably get an error in case if it isn't. I am located in New York, so I'm going to choose U.S. East North Virginia. That way, when I'm pulling my data from there, it will be as performant as possible. What I was talking about before was with a CDN. I misspoke a little bit. If you want that global read performance to be low. And then copy settings from an existing bucket. Well, I can pull in these from before, but let's assume that I don't have any buckets because all of you who are doing a fresh account will not have this. Folks are wondering why some of those buckets are not loading their browser. Not all of them are publicly hosted websites quite yet, but it means you're all paying attention. Cool. All right, step 2. All we've chosen is a name and a region so far. Next, we have something, this little checkbox here for versioning. Versioning is really valuable. When I think about all of the operations I would perform if I want to keep these entities in my bucket, let's say this is one of my objects. It's a little sticker. It here has the AWS logo. But let's say this object changed over time. Now, there are a few ways we can handle this if you just think about the ways that you logically deal with files. If this is something like a text file, we're used to in Git, we can actually get the diff and have a meaningful difference between the two. But one of the most important things would be, let's say this is my company logo, and I have this saved as my key as logo.png, for example. Now, when I build applications, I may want to, have them pull logo.png from Amazon S3. And so I can version this. Instead of having to completely overwrite the file, well, it will completely overwrite it. But if, let's say I want to roll back, or I want to have feature flags where I can, under logo.png, actually have different versions instead of logo1.png, logo2.png. I can actually do that, and S3 will manage that for me. So I can, keep all versions of an object in the same bucket if I choose to do so. So that's very exciting for those sorts of use cases. Also, depending on sort of how you have your lifecycle management for your data, which we can cover in just a moment, this helps to prevent you from blowing away, let's say, master copies of your data. So, Amazon S3 is inherently very durable in that, data that you put into an S3 bucket will have 11 nines of durability. But if you, write code that accidentally overwrites a file at the same key that you already have on there, without versioning, you may not be able to recover that file. So versioning could be very helpful for that. Just following through on chat in just a second. Yeah, so some folks asking a little bit about the regionality. So the bucket names need to be unique because they can be accessed directly as a URL globally. But the contents of the bucket and the actual infrastructure that the bucket lives on is region specific. I'm sorry, I probably caused a little confusion because I misspoke previously and sort of combined the namespace and how the actual infrastructure works, so I apologize. But yeah, namespace is global, but the actual location of the bucket and said contents are localized to a particular region. What I was meaning to point out is that here in the top right, you'll see that this says global rather than the region name. When you're in a console for other services, typically that is bound, and you will only see the resources you've provisioned for a given service in that region. Now here with S3, you will actually see all of the buckets that you've created, regardless of which region they live in, and the console type or region will switch to global. Okay, cool. Sorry, big detour, but I think folks in chat are caught up, so we're going to keep going. Another one is server access logging. So, sort of part and parcel to having data files that we want to store somewhere, we oftentimes are going to want to know who is accessing those files, and we would love to know, assume that it's just the good, rational, known actors that we have. Maybe we have a bucket that we only want our approved admins to use. Maybe we have a bucket that is set such that only our application should be able to, perform transactions against or put objects and get objects and so on. But there's no reason why we should have to assume that, right? It would be dangerous to assume, and that could lead to us being a little bit reactive, or quite reactive actually, to an intruder. So we have this nifty feature here called server access logging that we can enable. By enabling this will enable us to choose another bucket by which we can automatically have S3 dump the access logs to. So I don't have a bucket set up for this quite yet, but we could select one of these. And again, these are some of the personal buckets I have. And then you can enter a prefix. So this would be really, really handy if you have, like, you just wanted to say logs dash and then the bucket name, for example. Now I know that these are all advanced features that are not simply just creating the bucket and getting started. All of these are also available once you have already created the bucket. So I'm covering them here because they're available by default in this creation wizard. But I'm gonna fly through these and get to this sort of basic functionality before circling back around for some of the other advanced features. So I want to make sure we cover the most important things first. Questions from chat in the meantime. David Nugent wondering, can a user do versioning in a separate bucket? The practice of doing versioning in another bucket, yes. I'm not entirely sure if it's available first party to specifically put the output of a version to another bucket. But there are a innumerable number of ways to implement that functionality with S3, and in fact, that would be very common to have in some form or another. Because if you're thinking about data at your organization, right, like, there may be one golden source of truth, but you may want to have certain copies of them may be modified in different ways by different parts of your organization. So not simply just like an access control problem which we can address with IAM or ACL, access control lists. But the short answer is it depends on how you're trying to do it. The long answer is yes, you can do it optimally depending on what your constraints in your workflow would be. There may be more cost-effective ways to do that. We'll actually get into lifecycle management in just a second. We have some more advanced features in here. Object lock. We have CloudWatch request metrics. So, for example, we mentioned before here server access logging. So we want to be able to record logs every single time someone sends a request to hit our bucket to perform a certain action on it or any of the objects within it. Now, these are inherently logs, so think of a mountain of sort of time series events. Now, what we have down here for request metrics will be within CloudWatch. Actually, am I misconstruing this? Oh, sorry. So the S3 server access logging. Okay, we'll circle back to this one. But regardless, two different types of CloudWatch request metrics being, if I'm understanding this correctly, the AWS API calls, whereas the server access logging will be some more nuts and bolts of exactly what is happening to your data on the S3 service, separate from the API calls. But I'm sure someone will correct me in chat there. Cool. All right, so we promised it would be very easy to create a bucket, and I've spent a lot of time talking to you about advanced features, but let's get into something that I would definitely not consider advanced, but can be complicated at times, and this is permissions. So whenever we're thinking about data, at Amazon, and AWS, our motto is that security is priority zero. Because you can implement all of the best functionality in the world, but if your data is accessible by unknown actors or anybody essentially that should not have access to it, then you did it the wrong way. There is rarely ever an excuse to not have applications built in a secure way where only the right people or applications should be able to access them. But doing so may not always be the easiest. We're going to walk through sort of how to make this possible here. So there's a bit of nuanced permissioning that we can go into, and this sort of opens up the door for a conversation around IAM, Identity Access Management. But let's start here. Now, the baseline that I want everyone to understand is that when you create an S3 bucket, it is locked down by default. Nobody essentially has access to it except for, I believe, the admin that creates it, essentially. Now, when we and barring specific permissions that you then inherently grant to a person, so essentially by default we are blocking all public access. So if you're worried about creating a bucket and taking a mad dash to secure it, you can rest assured that it is secure by default in that it has no public access. However, the flip side of this security first approach is that we will need to open up access a little bit and in a strategic way such that our other applications and other users that need to access it can do so. And this is where a lot of folks get a little bit worried. Now, if I were to uncheck blocking all public access, we get this little warning here that tells us we can do that. And when we click on this, I can say I acknowledge that the current settings may result in a bucket and objects becoming public. And then from there, I could choose to, re-lock down some other portions of it. Now, we're not going to make this a public bucket. I think there are very few scenarios in which making your bucket public is something you should do. If I were to give some advice here, it would be keep your bucket locked down until you hit a permission error it requires granting of incremental further permissions. The strategy of applying admin permissions to everybody at your company and every application is not good, and you should not do that. But on the flip side, you should also not just open up your bucket to make it easy in the dev cycle so that everyone can easily access it. But because everybody in that scenario doesn't just mean you and your developers, it can mean anybody who's trying to access it. And like for example, I have some buckets here that could be public on stream, and there's reasons why some of that can be okay. One of the primary use cases here is if you have an S3 bucket that can be used to host a static website. Now, remind me, we'll cover that later. But that, again, a very sort of pointed use case where you want those objects and data to be publicly accessible. I think most scenarios where folks are storing data does not fit under that sort of criteria. Cool. All right, moving right along, setting some permissions here. Or rather the review of all of the settings that we went with. I went with the most default configuration that comes here in the wizard, so I didn't enable any of those features that I spoke about, so that if you want to get the most basic version of an S3 bucket available, you can do so. So we create this bucket. Also, we're about halfway through the broadcast, again, first episode of this series. I'm learning about how to do this in the best way for all of you in the audience. The big question I have for all of you is, do you enjoy me talking through all of these features as I go along, or do you want me to shut up and get to more of the interaction and actually using the CLI first? I'm going to keep going right now really quickly, but if you have thoughts on that, or you want to see more code, say that. If this is totally okay, just give me a thumbs up or something in chat, because trying to make sure that you all get the most out of this session for yourselves. Cool. So we have created this new bucket, and we can see it here. It's called Get Buckets Win Games. This was from someone in chat. Access buckets and objects are not public, and it's in the U.S. East region. We can see the date created here as well. Cool. All right, getting some thumbs up, but thank you for that. Cool. Awesome, folks. As long as there's not a show after this, we may run a little bit longer too, to cover more stuff. So we'll play it by we'll play it by ear here. We'll see. All right. So when we go into our bucket again, think back to good old bucket right here. It will not have any objects in it. It'll be nice and empty. And that's sort of by design, right? You don't buy a storage container or create containers that have things already in them. That would be kind of interesting. Here, it tells us this pretty bluntly. Bucket is empty, upload new objects to get started. So I'm going to show you some of these functionalities in the console, which is very handy to get started. And if you're really trying to get a feel for how some of these actions are going to, manifest themselves in the console. But then we're going to move over to the CLI. Now, when you're interacting with S3, much like every single other AWS service, unless there's an exception to my knowledge, they are available programmatically. Again, these are developer tools via the CLI or via an SDK. The AWS SDK, or AWS has native SDKs that are formally supported in, a very large number of languages. I can't remember the last time one wasn't supported. Even if you find a language where there isn't one formally supported, you can make sub-process calls to a locally installed version of the CLI, which is language agnostic. So in short, regardless of what type of developer or skill set you bring to the table, you will not be precluded from using AWS services. Anyway, enough of that little soapbox. So we have our bucket, and I mentioned before we're thinking a little bit somewhat like a file system, but really at the end of the day, S3 is a key value system. So I can put objects in with an assigned key. Oftentimes this is just the file name. I'm on my desktop computer here, so maybe we can upload a file. So I go to upload. And we see here to upload a file larger than 160 gigabytes, use the AWS CLI SDK or S3. So if you're uploading through console, you have this 160 gigabyte limit. But there are higher limits for when you're using programmatic access. Now, additionally, while we're here, this is a nice time to call out that there are a lot of workflows for uploading files to another location. Ones I can think of off the top of my head. Let's say I have one file. If I have a file that's small, all right, that's probably the garden path, quite easy, it uploads. Let's say I have a very large file. Now, we see here 160 in console is the limit, but if we're doing that programmatically, that could take a very, very long time. Now, there is actually a really cool CLI call for a multi-part upload. And if I understand this correctly, essentially what happens is that assuming the to prevent sort of this let's say either interruption of the file upload or to depending on what the bottleneck in your system is or on the server, you can essentially upload in multiple different chunks sort of in parallel. It depends on how your infrastructure is sort of laid out or where you're calling this from, whether you'll see an improvement in performance or not. Like if you have really low upload speed personally on your side, you probably won't see much. And it probably depends on the type of file. Largely, I see this with people use this as they have extremely large data sets and they're trying to upload. They'll use the multi-part upload functionality, or if they have, let's say, a movie. S3 sort of handles, and the S3 CLI will handle some of the messy bits of being able to sort of chunk the file without you needing to break it up yourself. Because one of the worst things would be like, I have this data set, it's too large, I need to make 20 equally sized chunks that all fit under an upload limit, or that, So anyway, that's multi-part uploads. We got a request for enabling access logging on the bucket. Actually, no. Can I enable access logging for the bucket that my access logging logs go to? And the answer is yes. Because that bucket, so I've got big bucket over here. Let's imagine that this little mug is, they'd be similarly sized because the buckets are both, infinitely large, right? But this is everything I can do in this bucket from a feature perspective has parity with this second bucket that I've created. The fundamental unit is still an S3 bucket, and all of those features can still hold true. So yeah, it seems like a bit of a funny question, but yes, definitely available. All right, cool. Let's get this show on the road. So I'm gonna upload a file here. Let's find something. All right, I chose an image. This is just a timestamp. Now, the global, the name of the bucket needs to be globally unique, but it would be a bit of a pain if every single object you uploaded needed to be unique as well. But thankfully, sort of through transitive property, if the upstream or the prefix, which is your for the domain for your bucket, is unique, anything inherently after that that you don't already have an object stored as will be unique as well. So this is just a timestamp for an image. I think it's just like a selfie of me drinking coffee. This wizard allows me to add a bunch of files as well, but let's just keep it simple. Now these are all properties that I can add directly on this given object that I upload. So when we're looking here, this is the owner, like the ID. I can give permission here, so this object's field grant permissions to the user to list, create, overwrite, or delete objects in the bucket. So this is essentially a shortcut to being able to provide access to certain users in my organization. So right here, this is just my the only user that I have in my account. But if I had multiple users in here, I may want to selectively grant permissions to read or write for them. So for example, if I have an application that let's say I have an account in my organization that's exclusively for my production application. Let's say it has its own IAM user for that and everything. Maybe that needs read-write permissions, but the latest intern that I hired that's looking at some dashboards or is going to craft some dashboards will not need to write to this S3 bucket. It's simply that person would simply need to consume that data. So read-only permissions would be sufficient there. That's just one example. And now there's another, and so this read and write is actually scoped to the given object for what they can do to the object. Now there is another set of permissions for the bucket itself, whether they can even see objects in the bucket. So listing objects in the bucket, for example, is a separate permission unto itself. We're giving all of those sort of across the board here for this because this is my admin user account, let's say. Cool. And then under public permissions, the block public access setting is turned on. This was available, but this was turned on by default. I have not changed this. So what this means is that nobody should be able to access this file that is not this particular user. And that's great. We want to keep it that way for now. All right, going next. All right, I knew we would get here eventually. So when you're talking about files, one of the folks in chat, David, I believe it was, wondered if you can do versioning within a bucket. So there are a few moving parts here when we think about versioning, but I think they play hand in hand with what we're seeing on the screen right here. So if you want versioning of different objects in the buckets, essentially the key will largely be the same, or the key will be the same for the object. So let's give the logo scenario before, where I have, this little AWS logo. And let's say this is logo.png. This is in my bucket now. I'm uploading an image here too, so it'll behave fairly similarly. Now, I may have a new version of my logo, and I want to make sure that in my bucket, the key is still logo.png. Now, what I can do is with versioning turned on, I can upload that, and I can, when I query objects going forward, I can specify a metadata tag for the version if I want to get the old one. By default, it will be the latest version of what's in there. Now, the way this works is essentially for those older versions, those are duplicated and stored sort of behind the scenes. But when we have older versions of data, the question starts to become, well, what is my access pattern around that data? I would imagine that, if we were performing a migration to our newest logo, that I would not very frequently be calling that old logo. Maybe there's a handful of applications that still have it, and eventually we'll migrate off of them. But what we have here in S3 are these various tiers for storage. Now here at the top, we have standard, which is going to be the highest tier in terms of performance around accessing of data. This is sort of the magic, O(1), like extremely quick to reach in. You pull the object out no matter how many objects are in your bag. But let's imagine that some of our data becomes cold over time. Let's say we only ever care about this logo and the logo right before it, and we do care about storing those really old versions of the logo from very, very long time ago. But if I could pay a little bit less to be able to access that in a little bit longer of a time, so the query was not as instantaneous as it would be for S3, I would want to do that. And so this is sort of where the lifecycle management of data starts to come into play. So if you can think about any of your files or objects that would have a key that you would largely want to keep persistent, or simply you have, let's say you have your logs, right? This is actually a good example for the log scenario that someone saw before. Let's say I care most about the logs that are most recent, and I'm trying to look for, the most recent access, and I have my site reliability engineers looking at that, right? After a month, I want to keep those logs around, but I don't mind if it takes me a little bit longer to query them. And so what can happen here is you can actually move those logs into some of these colder storage tiers. So the trade-off as you move down this spectrum is that it will take longer when you perform the get operation for your objects, from when that operation is executed to when the objects are returned to you, but you can significantly reduce the cost of storing those objects. And we think that, logs are one great example, but there are a lot of different forms of data that essentially become cold and don't need to be as accessed as frequently over time. And so you will understand your use case far better than maybe I will, but we can see here that, as the name sort of imply, we go all the way down to Glacier and Glacier Deep Archive. Here at the bottom, Glacier Deep Archive being files that can have extremely long query times, but you want to store at a fraction of the cost. The technology that powers some of these services is largely abstracted from you, but with the click of a dial to really showcase sort of how it can be so much cheaper. These are stored on S3's standard tier. These are stored on highly performant, always ready, always available. Technically everything is always available because the endpoint is always live and your data is returned, but near instantaneous sort of return of your data. Whereas if we go all the way down to Glacier Deep Archive, this data ultimately becomes stored on physical tape in the bottom, of frigid mountains. And so all of that happens automatically as you change these little configurations. So S3, again, this is one of those quality of life features that has come out that is extremely valuable and helps you save data, because otherwise you would store everything in standard by default, and that can add up over time. Cool. We're going to select standard for now because we want to be able to query an object and get it back right away. And also, there are some minimums here around how long objects have to be in S3 before they are eligible for these other tiers of infrequent access, one zone infrequent access, and so on and so forth. Some of the trade-offs here as well. Intelligent tiering, essentially, this is where AWS will actually determine automatically when some of your data is getting cold and intelligently move that, as its name implies. Now down here we see with standard IA, that's standard infrequent access. That's the, I use this data less often, let me move it here. It behaves largely similarly to standard S3 buckets. But when we talk about another vector by which we can reduce costs for the customer, I said that there are 11 nines of durability in S3, and that doesn't happen by accident. And there's a lot of heavy lifting that goes on behind the scenes to make that possible. But one other thing is that many customers may not need that level of durability. Maybe it's okay if this data for a fraction of the cost of those 11 nines, they would lose some of those nines of durability depending on that workload. And one zone IA is a tier that enables that to be possible. Cool. So I think that was a fairly comprehensive coverage. One of the things that we'll see here on the fees. I didn't explain the pricing model for S3 yet, so I figured now would be actually a good time to do so. If we really think about file storage or object storage, they're in an on-demand fashion. There are a few things. Now, I mentioned that when you provision an S3 bucket, just like this, that there's no bottom to this bucket, right? It's just I could just keep dropping objects in, and they disappear off screen, and they're in my bucket. I just know if I reach in, I'll pull it out. We did not, when we created a bucket, have to specify a size. You probably noticed that. So that's, again, intentional. There is no hidden limit of a bucket size where if I upload, like the entire trilogy of my favorite, movie franchise series or what have you, that I'm going to hit an imaginary sort of wall, and then S3 is going to yell at me to increase my size. That doesn't happen. So when we think about truly on-demand capacity, it's consistent with other foundational principles of cloud computing, which are pay for what you use. So when we're thinking about storage and access and management of data, we have two main vectors here. First is going to be the physical cost of the cost of the size of the data I have stored on S3 and for how long it is stored on there. So with the metered billing, essentially you are billed, I don't remember what the granularity is for S3, but probably per second, or I'd say per minute, but I'd imagine it's much more granular down to the second for the size of the data that you have stored on there. So you can deposit and withdraw data sort of at will, and you don't have to worry about getting billed for the whole month based on the single peak of data that you had on there. No, it doesn't work that way. You are billed essentially, for just the time that data spends on any piece of data spends on the cloud. Now the second, and that's really where this, this is not shown here, but that's in the pricing model. And then the second is you will have on the networking side, you get some data egress fees as well. They're not S3 specific costs. Those are separate from that. But really, what's more relevant here is that in these other tiers, there's a small fee to these others, these other infrequent access tiers, but largely when you're saving upwards of 10x on the per unit time cost, these per gigabyte fees start to become a drop in the bucket as long as your data is spending any sort of significant time there. Cool. Wow, we are at almost 10 minutes before the top of the hour, and I still haven't gotten to coding, so I'm gonna haul it a little bit. Just looking over at chat really quickly. We also have a comment around S3 object tagging. That's another fun quality of life feature that we can get to in just a moment. But let's finish this upload, man. We just created a bucket. We want to upload a file. All right, cool. So we saw a little progress bar there on the bottom, but largely this is a small file. A bit of an oxymoron. This is a small file, 64 kilobytes, and we have this little object here. So if we click on it, there we go. That's me sipping a coffee. Cute little guy down there. Anyway, so this is my file. I can view this directly on S3. So I mentioned there's two parts to the object that S3 manages. It's largely it is the actual data of the file that you uploaded, and then there's some metadata associated with it that can then enable some downstream factors, things like cold storage, right? So here we had last modified. So we could actually set a trigger for our data to automatically move itself into colder storage. But let's say it will downgrade its access tier from standard to infrequent access, or standard infrequent access, if it was not last modified date was 30 days earlier or later. Let's say that could be a very common sort of policy to do that for logs. Let's say. Then we can see the storage class here as well and size. So notice in a bucket, I don't actually need the entire bucket to be defined by a storage class. I can scope the bucket to, let's say, an application or an organization or what have you, and then individual objects within that bucket don't have to be moved to another bucket to move to colder storage. They can actually do so within this bucket. And this is sort of where the idea of S3 is key value storage and retrieval for objects rather than a file system, because if you're thinking about a file system, you have some hard drive somewhere and all of the files are on the same physical device. With S3, that's all abstracted away. Cool. We have some fans of the merchandise. I wish I could point you to where to get some of it, but alas, I can't. Message me directly on Twitter, and I will see if I can get you some stickers. I'll shamelessly plug my Twitter in the chat. I've got a handful of stickers. They're the props in today's episode. I've got some others as well. But without further ado, let's move right along here. So I uploaded a file, and I said this isn't a file system. It's key value. So you're probably wondering, Nick, what is this create folder little button over here? So we've got a few options. We can name the folder, sort of an obvious one there. We can use some encryption here. KMS is Amazon's AWS's key management service. We can use this default AES 256 encryption. KMS would be you bring your own key, let's say. Now I'm gonna name this like test folder. So it's very interesting because in Amazon S3, folders are not objects. A folder is essentially a pointer to another set of objects, and this is something that trips a lot of people up with S3 because they think it behaves exactly like a file system. So, for example, if I were to put some files in here and I were to just say delete test folder, well, S3 would not do that automatically. What S3 would tell you is it would probably throw an error and say, hey, test folder is not an object, and there are objects under this path. So the way you can think about it is that test folder essentially adds on a prefix where you can have logical sorting or logical bundling, let's say, of your objects. There are also a lot of implications with folders, sort of as gated triggers for other downstream applications. So this is very much sort of beyond the scope of today's broadcast, but in the event-driven programming model, one of the most common triggers for some downstream event to occur, some computation on the cloud, is oftentimes an S3 event. So a scenario here would be, let's say I'm building an application where I want to process that image that I uploaded. Maybe I want to, detect some objects that are in that image, or I want to apply a black and white filter on it, for example. In S3, I could have a folder that says, raw uploads, and those are, let's say, where all of my client applications are going to upload the images to. And within that folder, I have a trigger set such that every image will trigger this processing pipeline, and I could have another folder in here that is outputs, so that when I put the processed image in the output folder, that would not trigger a cyclical event. It would not trigger sort of this positive feedback loop where it just keeps processing itself. So test folders are largely sort of these like logical separations, but they don't behave exactly like like folders on a file system. So there are actually some cool quality of life features in the console that help you to get around this, where now you can, there's sometimes I think there's a warning if you try to delete a folder in the console, and it will recursively do this. I'll show you how this experience is fundamentally, this experience is simple in the console, but could be more complicated on the CLI, but not terribly so. Okay, so we've got this bucket, we've got this example file as well as folder in it. Now I have, let's see if this is going to work out. We're going to do, all right. So this bottom left right here, this is very small. I apologize. But I'm actually working on two different computers right now. So that's what we're seeing here. So what we're seeing is, over here, we have, my laptop. Let's say this is my dev machine. This is my console. Let's say you have an admin somewhere and they're working directly on the console. This may be you. Let's say this could also here in my dev environment. This could be this could be you on an EC2 instance on a virtual server. Now we want to be able to actually access the S3 bucket that we created. So we're here in a folder. This is just. I have this folder for today's episode. I don't have much in it. I have this index file that we may try and practice putting into our bucket in just a moment. So what we are going to do now is we are going to put. Let's try and pull down the file that we had. Now we're going to be using the AWS CLI here. If we do AWS S3 help, this is going to be a little rough. This is the local manual file for S3. It'll tell you a bit of the details. A lot of this is available in the documentation as well. But most importantly, what we care about here are some of the commands. So, we see if you're familiar with Linux commands, CP for copy, moving a file, RM, these are all actually valid commands for S3 as well. Now, some more exciting ones, maybe sync. Hopefully we have time to get to that one. We're at the top of the hour. I don't think there's anybody going on right after us, but John, if you could check on that and yell at me if that's the case, that would be super helpful. Otherwise, we're probably going to go for another, let's say, 15-ish minutes. Awesome. I got the thumbs up and in record time, so thank you for that. Okay, cool. So, we've got... exiting Vim impossible. So we have this empty folder. And one thing I have not shown here, which is a necessary precursor. If you're new to AWS, you will have to install the AWS CLI. You can do that in various methods depending on whatever your operating system is. But once you have done that, once you have set up your credentials, notice again, our bucket is locked down. No one should be able to access this who is not our root user over here. Now, I have configured my CLI with those credentials, so I should be able to, if everything goes according to plan, perform all of the operations that we want. So we can start very basically. So in AWS, then we have the S3 service, and then we're going to use LS. What this should do is list all of the buckets that we have available to this user that I have. And this should line up with our console. Oh, actually, that may have been... All right, so this is correct. I have a second user on the other terminal. So, we're doing it live, folks. Everyone makes mistakes. So AWS S3 LS is going to list all of those buckets. So these should look pretty familiar. These are actually the buckets that I have available right over here. So those are lining up. Again, two different consoles. Yeah, folks are saying it's readable for you as well. Oh, someone was saying my screen is blurry. I hope this is a little bit better. I just pumped up the size a bit, so hopefully that helps. Picture in picture is hard to read. Oh, sorry. Yeah. So I'm gonna try and not do too much on this little window. I just wanted to. I can bounce between them as necessary. I'm just keeping it here in case I do something on the client over here and I want you to see it come up when I refresh the page over on the other side without having to swap the screens around too much. Cool. So. Anusan Raj was asking, is it a must to define the region in the CLI command when performing S3 operations? So we'll see in a moment when I perform operations, like AWS S3 LS is against the global S3 service, so it will list all S3 buckets that are available. We notice here on this side that this bucket, for example, is in US West, whereas these are in US East. But this query over here for AWS S3 LS returned all of the buckets that I have read permissions for. So or within this account that I have viewable permissions for. So cool. And this is forget buckets win games. These are the ones that are locked down. Some of these other buckets have publicly facing websites or publicly facing content. So those may be accessible, but let's not worry about those right now. So anyway, we're back here in our terminal. We see all of these buckets. So largely we would not be able to see these buckets, or especially the get buckets win games bucket, if we were not properly authenticated. So that again, in the bucket category of IAM permissions, we have the ability to actually read the bucket or read objects within the bucket, and then we had the specific object permissions when we uploaded our test image that had read and write permissions associated with those. Now again, we should expect everything to have valid permissions. So hopefully that is the case. So let's test that theory out. So let's view all of the contents of our bucket. So we do AWS S3 and then LS again, but instead of not passing in any other additional parameters, we're going to pass in our bucket name. So when I made my AWS config, I defined the default region, but because the bucket namespace is global, and this is to answer the question from I'm blanking, but someone in chat asking if you need to pass in bucket region in these requests, you'll see here that there's nowhere where I need to pass that in, and that's made possible exclusively through the global namespace. So get buckets, win games, great motto, love using this. So this should, if everything works, return all of the objects in my bucket. Cool. So we only have two things in here. I know that's not too exciting, but we saw before that we uploaded the objects into our bucket. We set up our credentials, and I was able to pull down the objects in our bucket. So we see two here. We see this test folder pointer, and then we see this, which again has nothing inside of it. And then we have this file name. So this file name exists up on the cloud. We have we put it up there, but let's say this is not your CLI, or let's say this is an application. Some other part of your application stack has put data up on S3, but one of the most important parts about S3 is to be able to pull that data down. Now, that should be quite simple in AWS. So if we do AWS S3 CP, we list the source of the file, and then we have this not so pretty file name here, unfortunately. And then we put dot to have it move local. And so we see here it will give us this it'll give this little prompt, and again, very small file. So we have this available locally. And so I had that other index.html file locally. But I'm going to show you a really nifty trick that is beyond simply putting files in the cloud, sort of the pushing or pulling. I'm gonna show you syncing, because this is something that I think is very exciting. I actually use syncing a lot on some projects. So for example, if I have a I have a local dev environment, and I want to be able to easily, if it's static content, I want to host it as a website. There's a way to do that very easily with S3, where I can put all of my files in there. I point S3 at the index file. Typically, you'll name it like index.html, and it'll serve those files as long as you've made it public. Now, if I have my dev environment and I want to very easily, I make some changes, I want to very easily synchronize my local dev environment with the cloud environment, I can do that. So there's a sync command for that. And let's actually just sort of take a lay of the land of the state of each of these two environments. First is my local environment. So I have two files. I have this, this screenshot image, and then I have this index.html file. We can take a look at it. There's nothing fancy in it. It's just some boilerplate HTML that we'll see in a second. But I have two files, one of which is not on the cloud. And then on the cloud here, I have, in S3, I have this file, and then I also have this folder, albeit an empty folder. So one thing that we can do is we can do something called sync. So AWS S3 sync. We can sync this this current folder and say, hey, I want to sync these contents with Win Games. Now, there's an optional exclude flag. So in the dev environment scenario, maybe you want to exclude things like your, like if you're a JavaScript developer, your node modules. This would be a very common one. We see this as like when you're checking, especially if you think about your Git flow, you may have in your .gitignore file a, like your node modules directory, so that you're not pushing all those into your version control, for example. We could exclude, some local dev things if we wanted, but let's just run this and see what happens. So what sync is going to do is it's actually going to look at the states of both your S3 bucket, that's the target, and your local folder, and it's going to reconcile the differences between the two, essentially perform like a diff between them. And it's going to say, oh, okay, you had this, well, at least in this example, it said, hey, you have this index.html file that's not present up on the cloud. Therefore, to sync, S3 will upload that file. So I didn't have to specify that. I didn't have to say, hey, this folder, and this folder needs to be bulk uploaded. I simply ran this and it worked. Now, if I pop back over to my console, which is right over here, and I refresh, because this doesn't upload it doesn't update in real time, but as soon as the upload was done, if I refreshed, I could see right in here in S3, I have this, this file. Now, I guess there's no visualizer for text files in the S3 console in the same way that there is for images, but this is now up in the console, and anybody else could pull that down. So I'm personally not in the market for creating my own Git repository here necessarily on S3. That's a topic for another time, but that is a common workflow. People will compile static assets in a dev environment for their website, and then they can push those to S3. So Rocky Saxena is wondering with a great question, is the diff done by name or actual content? So you know what? So the only thing that is better than an answer is testing it live, and we will find out together. I have a hunch for what it will do, but let's figure that out, right? So we're here. Again, we have these two files. It's a little bit hard for me to make modifications to the image inline. I mean, I could open it up in a photo editor, let's say, but we'll edit this index.html file because this will be a bit easier. So right now this says, hey, this is a test. Now, if we want to test to see, I think the obvious case would be, hey, if a file name changed, that would be able to perform that diff very easily. But let's see if S3 will automatically pick up on changes that we make to this file. So if we jump in here, said, hey, this is a test. Then let's say, hey, Twitch, give you a little shout out for that wonderful question. This is still a test. Hardest part of software, exiting Vim. Nailed it. All right. So now what we don't have, and actually this might be a feature in S3, I'm not entirely sure. But like in Git, you could do like a git diff and see what's different between your local state and the cloud, or your source repository. Here what we're going to do is we're just going to run the same command we ran prior. We're going to run s3 sync and see what happens. Aha, so it uploaded index.html again to the cloud. Now, if you notice, the key remained the same, but S3 must have recognized that some of that metadata changed, or some of the actual, binary data within the index.html file changed, and as such, it uploaded. So there you go. Like that would be the equivalent of, like, let's say you have a pipeline where you have, like your maybe your graphic designer makes your assets and you upload to logo.png. You wouldn't want to change logo 2, logo 3, logo final, logo 4, really, really, really final, right? You'd like for this sync pipeline automatically do this. And so, sync is a very powerful sort of set of different actions that would happen where, assess local state, assess cloud state, perform the comparison. If target destination is missing files that are present or in local files, or if there is a binary data mismatch, then upload all files to cloud with the same key. And if there's if an entire file is not present, then just upload that entire file, right? So a lot of really sort of hairy stuff that can go on behind the scenes that a lot of people in the past may have had to implement. I don't know how far back the implementation of the sync functionality goes, but that's something that I know has a lot of different use cases. So Rocky Saxena was wondering, what happened to the file. So remember, we didn't set versioning in here. We can walk through what that looks like now after we've created the bucket. But what we would expect, the behavior we'd expect here is that if we pop back here, that object should essentially have overwritten the old one. So there will be no record of the older version. Now, you're probably wondering, Nick, a lot of folks probably want to be able to protect their data sort of by default. Why is versioning not available by default? And it's a valid question. It's a valid concern that I think most people would have. One of the philosophies at AWS is that we try to we do not want to charge you for features that are not required to use the service if you don't opt into them. Essentially, we don't want you to say, oh, I wouldn't have used that feature if I knew I would get charged for it. And so when we think about what it takes to actually implement that versioning, because that is additional storage that's required to store those older versions, that cost does get borne by the user, but we don't want you to start off on S3 and have that be a surprise to your bill. So it is opt-in, as most features are that will cost money. Now, there are a large set of features on AWS across many services that will not cost money, and those will be enabled by default most times. That's sort of been the recurring trend that I have found. Someone was wondering, is the sync two-way or one-way? The sync is always one-way. So this is why we don't run into things like a merge conflict if we have a bunch of files that would be very different environments or very different states between two. So the first parameter is going to be your source, and the second parameter is going to be your destination. So our source here was our local environment, and our destination was the cloud. But if I were to upload another file to the cloud and then do a sync, instead of like copying manually that file down by ID, I could simply do sync with the parameters reversed, and then it would download locally to the client any files that were not present locally that were available on our S3 bucket. shout out to from MX Blue, and shout out to a tool called rclone, a nice tool that allows two-way syncs. I haven't used it personally. It's not officially AWS supported, but there are lots of tools that are wonderful, that are not formally built by AWS. So a great call out if you're looking to do something like two-way syncs. The S3 APIs and the CLI, the SDKs enable you to build these functionalities if you so desire. The features that I show you in today's broadcast are not only not the entire set of features that S3 is available with, but also not the finality of what you can build on top of these. So a pointed question here. Well, actually, no. First, can I do a sync between two buckets? Will S3 transfer bucket to bucket, or do I have to go through my computer? Great question. In the same way that this S3 parameter, this S3 destination, or this URL is simply an S3 prefix by bucket, and then bucket name, and then I didn't specify a folder. This can be, you can use two S3 buckets and folders as sources and destinations. You can do one folder and another folder in the same S3 bucket. You can do two entirely different S3 buckets. If you have valid permissions, you can do probably an S3 bucket. You could do cross-region S3 buckets. So the question before around versioning and where you keep those different versions, if you wanted to, let's say either if you didn't want to go the CDN route with something like CloudFront for serving static content, let's say you wanted to actually keep a replica, let's say even disaster recovery, for example, for S3, you could imagine a whole region would go down, extremely improbable, or maybe you wanted some reason why you needed that data in another part of the world. You could simply have a monthly, a cron job that performs a sync on your buckets nightly, and puts them into another region or something. Or your cron job could be at any frequency. It's just an example. Likewise, you could have when you're trying to scope permissions for buckets and folders, if you want to make it easier, you could have a bucket that's simply just all of your old logs that you just want to sync and make sure that you have this one golden copy of all of your logs that's extremely cold storage, but you keep them in warm storage, in the warm storage tier on your current bucket until they fall off for the month. Lots of different things you can build on top of this. Anything you can imagine with file getting, putting, and syncing, essentially. Instant Mac wondering how often do these sessions happen? This is useful content. That's a good question. So at this channel, we run content all of the time. We're not quite 24/7. We try to keep an up-to-date schedule down below with our programming. But the programming that we run on this channel takes many different forms. Today is very informal, very casual, no clear plan. We're just sort of trying to go on this journey together around S3 and an introduction to it. But there's some other shows that we run that are maybe deeper dives, sort of 300-400 level content if this were 100 level. Sometimes we do talk show style content where you'll have maybe some guests from the teams that built services just like S3 talking a little bit about the nuts and bolts behind it. Maybe they just released a new feature. One of the shows that I run covers some of the latest launches. John in chat actually runs his own show where he answers Stack Overflow questions live. He's one of the most prolific question answerers. I won't derail too much from the topic at hand here at S3, but if this is in any way interesting, throw us a follow and you'll probably be notified next time we go live. But lots of different content that we run on this channel. So welcome. Cool. So let's think, folks. So we've put an object through the console. We could download it as well here, so I'm not going to show that, but it's fairly intuitive. You can download this directly. You could copy the path. So if we copy this path, let's see what that would look like. This is very, very tiny, but we see this S3 URL. So in the same way before, you may be new to S3, or maybe you just want to take a little shortcut here. Oh gosh, you didn't. Let's say, maybe I have a bunch of folders, right? And I'm very deep. I don't remember all of the nesting structure to this. I know a very particular file, or I can just pop in my console, find one of the files I want in the right directory. I copy the path, and then over here, it's showing me that, that path right there. So that's a neat little shortcut. Again, this is a trivial URL, but as you start to get more complex or very large buckets, this can be quite a pain. And when you're dealing with log files and auto-generated numbers, you're not going to have pretty names like index.html, for example. All right, cool. Moving right along. Let's introduce some of those advanced properties that folks were wondering about before that we didn't enable at start time, and that's a valuable call out. There's sort of two big things when it comes to how you enable these features. First is security. When you're talking about security, my advice is lock it down by default and then ease off the permissions or grant access, opting in for particular users or applications that require it. Everything else, all of these sort of like quality of life features, they're enableable after the fact. Now, obviously, there's some particular considerations here around like logging, for example, right? If you enable logging down the road, logging will only begin at the time that you start logging. So you will be missing any logs prior to that because they don't exist. Outside of that, a lot of these are fairly simple or straightforward to be able to implement after the fact. So with encryption, for example, let's say we want to add encryption down the line. I'm, again, focused in here in particular on this one object. Now, with the CLI, one thing that all of you are probably realizing is, every one of these particular commands and parameters and feature flags that I'm flipping around here in the console, these are all configurable in JSON, and they have their own, like you can, any action I'm performing here in the console has an analog over on the CLI or over on the SDK. So you're probably wondering like, hey, I saw a bunch of checkboxes. Do I have to check all of those and then enable encryption like that? I mean, very, very bluntly, you could simply recursively iterate with a little flag across all objects in my S3 bucket and enable encryption for all of them. So if you're thinking about all these like little tips and tricks you would use with, your own code, a lot of those work with the CLI as well. So yeah, we can enable encryption here, AES 256, one little checkbox. We can assign some metadata around here. So metadata is valuable for many reasons. There's a distinction between metadata and tags, so I figured we could just cover that really quickly. So again, I mentioned objects in S3 sort of have two primary components, first of which is the binary data, and the second is this little thing over here called metadata. Now, when S3 cares about metadata because there's some particular things that it does under the hood to optimize the transfer of data and how it can perform some of those magical functionalities like multi-part uploads. If you ever have tried to implement any of that functionality like multi-part uploads, you probably quickly learned that you start diving very deep into the nuance of how video encoding works and how you end on one frame and will then rebundle together the start of the next chunk that you did. And same thing with text and new lines and all of that. S3 does that by default, but it does need these little values for this. And in the S3 CLI, when you upload through the SDK, it can understand these itself, so you don't have to specify them. But we do find that here. So in particular, we have this content type metadata field key by default, and the value here for this index.html file was text/html. So we can delete this if we want. This is available by default. We can also edit it manually if we so desire. There again, you see some things like application PDF, gzip, zip files, GIF images. So these should all be detected by default. You can also do simple things like filtering when you're trying to access or perform operations on objects in the bucket from the CLI or the SDK with this field. So think of the metadata as sort of like intrinsic properties to the file. You can change these, but they should be largely matching the intrinsic properties of the file. I don't know why you would want to change this unless it was improperly identified for some reason, or maybe there was, like your data was corrupted and as such it wasn't, like when you exported a file, let's say, I don't know. But you can edit that. You can also add metadata. So let's see some other types of intrinsic properties that we can add here. Things like cache control, content disposition, content encoding, content language. Content language is a really good one. So, all of these are just properties. They're not intrinsically good or bad. I'm being silly. But something like content language is very valuable. So let's imagine you have like a repository of articles, or let's say you're running like the AWS blog team, for example, right? You may have a pipeline by which an article is produced in one language by the native language of that author, but then it will need to be translated to multiple other languages, right? So we could do the song and dance of having a bunch of folders and creative file names around that. But one of the really neat things we could also do is actually just have this metadata tag for content language, and then fill that in. So when we perform the S3 upload, we can specify these other metadata tags if we so desire. We can have an expiration by which, and forgive me if I'm misspeaking here, I believe if you set an expiration for the file, this would be something like a date time by which you could then have another application that would read that expires metadata tag, and then it either deletes through that application or it will self-delete through S3. I'm not sure, I haven't implemented that myself. A little bit of a self-destruct sort of metadata tag, and then this would be like I think this would be like for cross-origin allowing of access to resources if you had, like, let's say static website content that you wanted to limit or grant permissions to. Okay, cool. So that's again a bit on the performative side, of like, how am I handling filtering or working with my data based on intrinsic properties, let's say. That's metadata. Now tags, this is entirely oftentimes for me, I think of this as like quality of life. Like, hey, I want some optional terms by which I can label some of my data that's being put in S3 so that I can more easily query it. Anybody who's a relational database or even non-relational database admin is thinking about their data modeling and all of that. And while S3 is certainly not a database in that it's performing these these transactions in the same way, I may want to attach tags because I don't want to have convoluted file system structure or folder system structure that makes it difficult for me to perform the operations I want. So I think something that you may be picking up on here is that there are a lot of different ways to sort of solve the problem of how do I, in an S3 bucket or across multiple S3 buckets, take this super set of files that I have. I've got, these business cards. Some are for me, some are for my coworkers. They'll be accessed in different ways. I have these stickers over here. They belong in this bucket. There, depending on your workload, there are many different ways that are no more or less correct to solve this problem of how you can model your S3 buckets and your data in your folders in order to access them. Now, my recommendation is this. There are a lot of tools at your disposal here by design so that you don't have to feel like you're being forced into a model that is not intuitive for you. Now, workload types and access patterns will exist in every way, shape, or form across all of your applications that you'll build. So we've tried to build the tools here with things like tags so that I can add an arbitrary key here, and then I can use that to perform filtering on the CLI. So let's say I have something like, maybe I'm a game developer, let's say, right? And I have a bunch of different games. And so my key here would be the game that the asset will belong to. And then my value would be like, like default, or like it would be like, Faction 1. Let's say we're playing an MMORPG. I won't give names, but maybe you have two factions against one another, right? And so based on this, we could very quickly perform a filtered S3 operation from my client, where your client won't download all of the objects and then simply show you the ones that satisfy the filter. It will pass on those filtering constraints to S3, and on the S3 service side, will simply return the valid results for that. And if you're ever managing this own sort of like middle tier layer yourself, you would need to build in your own application tier that allows for building those that tagging and all of that by default. So I can add the game. Oh, actually, sorry. I would add game, and then the value here would be, whatever that would be. And then let's say it would be faction, and it would be like the red side, let's say the red faction versus blue faction. And then game here, the value would actually be like Nick and Friends Twitch Adventure, right? And this is keys and values. So let's say this is, I don't know if this is, I think this is string by default. I'm not entirely sure. I'm sure someone in chat will pop in and know. Yeah, Instant Mac talking about in chat about permissioning. It is certainly easier to figure out that you accessed your bucket, didn't have permissions, and went back and struggled to make sure that they were rightly applied, rather than that you left your bucket open and that other people were able to access your data. It's a very I understand it. It's very easy to sort of think early on, like, hey, I don't have any sensitive data in here. I'll just leave it open. But it is just as easy to forget that you left that bucket open. And that's how, data exfiltration can happen. Other people can get access to it. But again, remember, by default, your data is locked down. So if you resist the urge to just turn that bucket wide open, and we've tried to do our best to give you some sufficient warnings there, you will carefully and deliberately give opt-in opportunities to access that data by adding those permissions. Cool. I'm just going to leave this. I'll see if this throws an error. Cool. So yeah, so we have our custom tags that we applied there. We have our metadata, content type, and then we have object lock. Now we can't enable object lock for this object because object lock has been disabled for the bucket. And reading this little tooltip here, interesting. Okay, so object lock is actually one of the features that you do need to enable on bucket creation time. So fun fact, we learned that one together, Twitch. So just close that one out. Cool. So that was properties. For permissions here, we can see a few other things. So again, remember when we added this object in here for index.html, we saw we were able to give permissions and scope permissions for this user that I'm signed in as, but we can change those here. We can add access for other AWS accounts and do that on a one-off basis, or automate that over the CLI if we so desire. And then here's one that, I wish I was a little quicker today because there were a lot of really cool features I wish I could talk to. But there's some other. I won't leave you today without being able to point you to places to learn about these further. I keep talking about how S3 is not a database because it isn't. It solves a different set of problems and it operates at a price point that is more commensurate with the long-term storage problem rather than reconciling transactions and lots of other things that databases do for us. But you actually have the ability, and this could be valuable for folks that are using S3 as sort of a repository for their data, and it's an extremely common use case, so don't think you're alone in doing that. But let's say you want to perform SQL queries on top of, or execute SQL expressions on top of your S3 data. So let's say you have logs, and in those logs you have like there's a bunch of metrics that you have, and they have different parameters. Imagine it's like like you have columns essentially, or for each of those different parameters. You can actually in S3 perform some SQL queries on top of that. And I know that starts to break down the mental model a bit. We were working with the world's smartest bucket here. But when I want you to think about S3, I want you to think about S3 as much more than just a bucket. S3 helps you make these buckets, but it helps you manage all of the objects inside of the bucket. It helps you manage who can reach the hands in the cookie jar on top of it. It helps you manage the way to efficiently craft queries to get that data out of it. And that's where S3 really shines, in my opinion. If you simply use it for nothing more than highly durable, cost-effective object storage, you get your money's worth. But the second you start putting a significant amount of data in it, these questions around how do I implement some of these other features, whereas in the past that may have required you to loop in other parts of other compute layers or other services where you write more custom code on top of it. We've moved some of that undifferentiated heavy lifting into S3 if you so desire. You may not want to perform SQL queries directly on S3 for some example, right? Maybe your SQL queries need to be transactional by design for your application, and so you wouldn't use SQL to perform transactional queries on ACID compliant transactions on your S3 data, maybe. But maybe your data scientist or your data analyst is familiar with SQL. Well, now they can more efficiently access your data on S3 instead of requiring them to learn a bit of the ops and install the AWS SDK and so on and so forth. Cool. Popping back over to chat for just a moment. So a really interesting scenario proposed. So someone in chat mentioned, and let me know how you want me to refer to you because your username is a little hard to pronounce. But there was a scenario where they had, let's say, a self-managed SQLite database, either on premises or maybe it's managed on their own virtual EC2 instance or an EC2 instance on the cloud. They use the use case with S3 as a backup for their database, and this is a really common use case. Actually, this is actually how depending on your implementation, some of the AWS databases have options to record snapshots to S3, for example. So whether you're manually managing that sort of that backup or that fallback set of your database, or you're using it through some of the AWS managed services where it asks you, hey, I'm spinning up a relational database through like something like RDS, relational database service. Which bucket do you want to use to store your snapshots? It's a very common use case, and we dog food this service internally. I would not recommend these patterns to you if we didn't approve of them, and in fact we use many of them ourselves. So it's a very good call out. Talking about undifferentiated, making a joke about undifferentiated heavy lifting and going to the gym. I wish I could go to the gym. It's unfortunately closed near me right now, but we'll get there eventually. Okay, cool. So let me take a peep at my notes really quickly, see if there's anything else that I wanted to get to. So let's walk through that sort of recursive step. This can be a bit of a fun one. So imagine I've got this test folder here, right? And if I tried to delete this folder, it would tell me, okay, it can just be deleted. There's nothing inside here. But if I create another folder, so nest1, and then I create a folder inside of this, nest2, and then I create a folder inside of this, nest3, you get where I'm going. The point is that if I ever try to perform a delete operation on any one of these folders, it will not allow me to because there are contents within it. So this is good because it helps us by default prevent ourselves from getting in our own way and deleting all of our own data. But what this will require is, for any of my algorithms folks out there, we'll have to recursively loop and see, okay, well, there's a get operation in S3. So I'll say, okay, let's say I want to delete everything within test folder. I want to delete test folder. It'll say, can't delete test folder. You have contents inside of there. Okay, well, what are the contents inside of that? It's nest1. All right, well, let's try to delete nest1. You have contents inside of that, and so on and so forth. So I'm sure you can all imagine a world where I use the get operation to recursively trawl all of these folders and then delete the one at the tail end that has nothing in it, and then I go back up the tree and I keep deleting everything inside of that. But this may not just be like a linear tree. You may have a bunch of different branching, and it gets ugly real quick. You shouldn't have to perform a depth first search to delete files in S3, right? Rocky Saxena is saying bye. Thanks for tuning in. I'll see you around. But yeah, so you don't want to perform that. So let's drop over to here, back in our terminal, back in the saddle. And so I want to perform a recursive deletion of objects. Now, let's just upload a file into 3 so that we have something in here to make it valuable. I'll just upload another one of those images. Cool. Following all the same steps. All right, we've got an image in here. Now I am going to try to delete with the remove command, if I'm guessing correctly. Well, actually, yeah. So rm, then s3, then my bucket name is get buckets win games. And if you're faster on the trigger here in these commands, feel free to throw them in chat. It's doing a bunch all at once. But yeah, so we want to remove. We don't remove the entire bucket. No, that would be kind of scary. What we do want to remove is this folder here, test folder. So let's see what this says. Did that work? It did not. So, and we can see that if you go over here. So if I reload my console over here, this test folder is still there. John says it deletes the 0 length object, but not the pretend folder. Interesting. Okay, so let's see what this returns in console then. If we're over here and we try to delete, so action, delete, and some of this may have changed. Maybe they enable this by default here. So all affected objects. So in console here, this will enable us to. It will automatically recursively go and delete all of those objects. So what we do, yeah. So in console, it will perform this command that we're about to run. but a little bit of trickery over here. So we will do AWS S3 RM, get buckets, win games, test folder, and now we can actually just pass in this recursive flag. And when we run this, we actually see that each one of those different objects was deleted. And maybe I was wrong with the nomenclature before. Maybe technically folders are an object. It's a metadata with no binary data, or the binary data is just the pointer or what have you. But we see here that it deleted, each of these given objects. Oh, show the screen. Oh no, I didn't. Oops. I thought I had changed screens, but so basically just going right up here, I ran AWS S3 RM test folder, and it said that it deleted this. This was the output from the CLI. But when we looked over here, we saw that this folder still existed, and all of the contents within it still existed as well. But if we go back over here to our CLI, when I ran this other command, so the same exact command with the same exact destination, but I passed in a recursive flag, it went in and as it was deleting these each popped in real time sequentially, and it deleted all of these. So if I refresh my console over here, we should be able to see all of these deleted. Great. So test folder is deleted. Climax of the episode here being deleting a bunch of nested folders, not terribly exciting. But again, this is a very much introductory lesson to Amazon S3. So we're nearing the end of the broadcast over here, but I've got a few minutes left. If you have any other questions, please get those in. I'm going to now pull up a bunch of resources to provide to you so that you can move forward with S3 and learn a little bit more about some of those other features that I spoke about. So if you have any questions, comments, concerns, get them in chat right now while I start to pull in some of these features. Just give me one moment. I was a little vague about S3 server access logging before, so dropping that documentation link in there. Type Theory wondering, when is S3 getting transactions? It is a very interesting question. I personally do not have the answer, but I think more on a philosophical level. When we think about software, there are always trade-offs that are made. And when we think about database management systems, databases broadly, the question of how do I store and access data is databases, and each different database answers that in a different way. Amazon S3 answers it in a very different way as well for a different set of problems. So when you ask me, how do I store and manage my data, I have 1.5 million questions to come back to you to ask you, largely surrounding what does my data look like, i.e. how would I model my data, what are my access patterns, what parts of my data are hot or cold, or how should I deal with that, what is the lifecycle management of said data? And then lastly, what are my technical constraints or my use case constraints? These are going to be things like how quickly do I need to get access to that data? How do I handle multi-tenancy, like multiple people trying to access a single piece of data at the same time? What do I need with respect to the latency by which when a write occurs that the next read will have that updated piece of data, your resistance to that, location of data geographically. I said 1.5 million, and I really wasn't joking. I could keep going, but there are a lot of different things. But S3 is a very exciting service. It's again, I said it is certainly not the latest service from AWS, given that it has been around largely, maybe not quite from day one, but shortly after day one. But there are continuously updates to it, and we truly do dog food S3 internally. There are so many services if you're new to AWS, you'll find that whenever you're configuring a resource, if you want to enable logging, you'll notice that it'll ask for an S3 bucket to put the logs into. Many of the AWS services are actually built on top of S3 as sort of the foundation, and that's where we feel very confident about those 11 nines of durability. We want you to feel confident that when you put data into S3 that you can expect that it'll be there and have it not be corrupted. and that, largely that it's easy to work with. And I know we covered some basic functionality today, but if you've never used the service before, I hope you're new to AWS broadly, I hope you feel empowered to be able to register for your account or hop into the console, hop into S3, and start creating your own buckets, putting some data in there, pulling them from clients, maybe installing the SDK in your language of choice. I know we didn't get to cover that today, but in the same way that these CLI calls were, fairly straightforward, logical, had a few parameters, the SDK calls are quite similar, where you designate the bucket, you make sure you have your credentials being ingested, and then you can specify the files that you're trying to put or acquire by key. So quite a similar experience. Let's see what else is in chat. John was wondering if I can explain the concept of a pre-signed URL. Yes. So this one's on the tip of my tongue. A pre-signed URL is essentially, John, and correct me if I'm wrong here, where you as a user or a client, let's say I have a client application, and as part of my application, maybe it's a mobile app, users will upload photos. Now, I don't want to give the end application, permission to view all other users' photos on that on my S3 bucket. And in the same way, maybe I don't want to have to make a new folder every single time a user, uploads a file or creates an account or so on. When you put an object up on the cloud, what you would like to be able to do through S3, let's say you do send like this put object request, you want to be able to know the location of where that object will be and have scoped permissions such that you can query and get that object back. So if I'm explaining it correctly, John, and correct me in chat, essentially, if you can enable something called a pre-signed URL when you upload an object to your S3 bucket, such that the client, as a part of the callback from that put object request, S3 will tell you the URL that object will live at, and as long as all of your credentialing was set up properly, you should have access to that URL that is pre-signed to give you permissions to access it. So a very common use case and a very powerful feature. Yeah, John put it far more succinctly than I did. I'll read his out loud. A pre-signed URL is a time-limited URL, so again, you can actually time-gate it that grants temporary access to a private object, or it can be used to upload an object. So maybe you have a private S3 bucket and you want to give someone sort of one-way door access simply to upload a single object at a single endpoint or a single address. You can do that with a pre-signed URL as well. Lots of folks in chat wondering if these sessions will be recorded. Yes, they are. I can pull this back over here and show you. So we're getting a little meta here, but if you go to twitch.tv/AWS, all right, there's that handsome fellow over there. But more importantly, what you are looking for is videos. So we can click all the way down here. We go to videos. We see our live stream still up here. We're in a little bit of inception. You'll notice a bunch of the other shows that we run, we try to categorize these in playlists here. After I select it as a highlight, just a small little flip switch I have to flip, you'll be able to find that right here. If you go to recent highlights and uploads, you go to view all, you can see it all on here. These are all of our streams. We have many. We're nearing the end of the broadcast here, so I guess I'll be giving us a little bit of the sign off. But if you're new here to either AWS or to us here on the Twitch channel, welcome. We're very happy to have you, and I hope you've enjoyed your time here so far, but we do a lot of content similar to this. Various degrees of difficulty and complexity, all different types of shows focused on different things. Here we see one that's focused on sort of talking and interviewing. We have one where we cover some launches, a show focused on containers, serverless application model. John's show right here in chat, he does one where he answers Stack Overflow questions live. So lots of different content here on the channel. It's always live streamed, or to my knowledge, almost all of them are live streamed. If it's not, they'll probably let you know. But again, developers, let's code. This was episode 1. This was our new show to try to get sort of more of a conversational style going. And help folks that may not be familiar with AWS, because a lot of our other content on this channel does make that assumption. We know that even something as straightforward as storing and managing your files is something that folks are still new to for different reasons. But we wanted to make sure we could sort of meet you where you are. Oh dear, I have this inception going on over there. Um, but yes. So we are very excited to have had all of you. We are nearing about 2 hours here. Let me leave you with some documentation on getting started with S3. So I'm going to drop some links in the chat. This is the getting started page. You can download or see the documentation for the different AWS SDKs for the languages of your choice. There are also a large number of resources on here that you can peruse sort of at your at your liking. Some of these are topics I've covered today, like Introduction to S3 and signing up. Actually, sorry, these are the step-by-step tutorials. These are actually AWS training courses that are free online courses that you can register for. So if you liked material sort of like today's, or you had instructor-led, these are going to be more along those lines. So you can sign up through those here, and they have some descriptions of those courses. If you would prefer to take the next steps yourself and just fill around at the terminal, I don't blame you. I've spoken a lot at you today, so you probably want to get to work. We have a set of 10-minute tutorials here where you can perform a lot of the things like we did, so storing and hosting a file. There's another flag for batch uploading files to S3. So let's say I wanted to upload, let's say I was going to use S3 for the first time, and I bought in that I want to migrate my file storage onto here. You could do a batch upload to S3 and achieve that quite easily with this tutorial. Hosting a static website, this involves some other sort of tangential and complementary services like Route 53 for DNS and CloudFront for, Route 53 for as I believe it's a registrar, and or DNS and CloudFront as a CDN. Yeah, so Route 53 DNS, CloudFront as CDN. I'm mixing up the acronyms. And then replacing backups with S3, so you can replace on-prem tape backups with S3 Glacier Deep Archive. So some similar scenarios that I posed today, but for just getting started on day one with S3, I think those are a bit deeper. There are also some more pointed videos on here that may be a bit more succinct than I was today. I tried again to add something that we don't necessarily have as much of, but if you're interested in sort of the nuts and bolts, very quick 101 feature set, as well as a deep dive on the storage classes from reInvent, there's a lot on there. So that one link that I dropped in chat before has access to all of these, as well as here at the top you can see some of the things around the other features. But there is really so much to use here, and one thing I will sort of end on is that whereas S3 may seem like the problems it solves are simple, it does so with it delivers an immense amount of value. The feature set that S3 has grows not just over time because new features come out, but I feel like at different points in your organization's growth and usage of S3, there are a lot of these really nice quality of life features that will not just make it easier to perform very difficult tasks, but save you money in the long run. Early on, you may be paying standard price for all of your data, but then as you grow, you have other data you want to keep around. Maybe it's not as hot. You can move it to infrequent access. You can save some money on that. S3 is something you truly don't grow out of, either be that the size of the buckets that the service creates, or sort of how your application's maturity grows and changes. S3 will always sort of be there, and it will be there certainly with other applications that utilize it as well, even if you don't use it directly. So cool. With that, I believe that's gonna about do it for us today. I'm at about 2 hours now. We planned to go for 1 hour. We thankfully did not have anyone going on after us. But please, we'd love to hear your feedback. We don't really have. I've been watching chat. John's been watching chat. But once I sign off, chat is kind of gonna end up disappearing. It'll still be on the VOD. But if you have any feedback, please reach out. We're happy to hear it, positive, negative, anywhere in between, anything you'd like to see on the show. We will have a page in the future, I believe, that will have the schedule. I know many folks have asked for that. The schedule is on a week-by-week basis right now in the lower part of our Twitch channel, but for this show in particular, we are working on getting a dedicated page for all of the future episodes. Today, again, we covered storage, storage in S3 in particular, object storage. Databases will be another episode unto themselves, maybe even multiple episodes, because there are lots of different managed database offerings at AWS. And I'm not entirely sure what episode 2 is yet. I'm trying to hint it to all of you who might be here, but I don't want to be wrong. It is probably in the wheelhouse of compute. I don't quite know if it's serverless with Lambda functions, or if it is maybe EC2. for virtual servers, virtualized servers with Amazon EC2. But it's probably one of those. We may also have Amazon or IAM, Identity Access Management, high up in here. I alluded to it today, how it can be used to grant nuanced permissioning to objects or buckets, but it can do so much more than that. IAM is the sort of like the metering tool that you will use to assign and delegate permissions to users amongst your organizations and have roles and privileges. And even AWS services or applications that you build will be given IAM roles such that it can control permission to access other AWS services, applications, and resources that you have in your account. So lots of fun stuff to see. Oh, John beat me to it. John, I don't know what I would do without you. I'm gonna have to have you back for the next episode as well. John dropped a link in chat. So the AWS Developers Let's Code link is John just dropped it in chat. It's right here. So you can register now for our events. I believe if you enter the mailing list, you'll get notifications for future episodes as well. We had episode 1 today, July 29th. 28th if you're here in the States still right now. Next up, we've got virtual servers, hosting your app in the cloud. We'll do something a little more, I don't want to say hands-on, but I think that it will be a little bit living in the terminal a little bit more, actually deploying an application, even if it's just something simple and straightforward. And then episode 3, very exciting stuff. We've got serverless. I know many folks are keen to learn that, and authoring serverless cloud functions with Lambda. And today was very crucial into understanding that episode, because we will show some really cool use cases with Lambda where events like uploading an object or an image into S3, like today, I talked about that use case to trigger a downstream compute like in a cloud function. That's what we're going to do in that episode. So each episode's kind of standalone, but if you got in today on the ground floor, you've got a little bit of a leg up on everybody that'll come into that episode. Awesome. Well, my voice is going, but thankfully I think I've said all that I have had to say on today's episode. Thank you again for tuning in. Developers Let's Code, episode 1. My name's Nick Walsh. I've had the privilege of speaking with all of you today, being able to make AWS and our services a little bit easier for all of you. So thank you for that. We're always looking for new ways to improve the show. Throw us that feedback. I'm on Twitter. I'm also on other shows. So if you pop in, you see me in here. You didn't like today's show. You didn't like that. I used stickers and business cards as the examples and buckets. Yell at me when I'm on another show. I'm happy to hear it. But thank you again for everyone for tuning in. We will be back with some more content at sometime probably in a few hours. You can check the schedule right below. If you are just tuning in for the first time, you will and you registered for today's event, you should get a link and all of that to the VOD after the fact, the on-demand video. You'll also get notified about future events. But if you want to get notified for any streams that we do here on this channel, you will want to follow on Twitch. So if you make a Twitch account and you follow there, you'll then get email notifications for that as well. But the registration that you had means that you will get dedicated email notifications for this show in particular. But again, that link has all of the other episodes. So someone wondering, are all of the VODs stored on S3? That's a very interesting question. Twitch manages that. That's a little above my pay grade for how Twitch is managing all of their VOD storage. But I did do an episode talking about the launch of IVS, which is the technology recently launched service that powers the real-time streaming that we are using right now. So maybe I shouldn't fall back on me not knowing about how Twitch runs. Lastly, Brad's wondering, are there only 3 episodes or are the rest just not planned yet? It is the latter. We plan to have quite a bit of these episodes, and the idea is to actually continue to grow and reorder the other future episodes based on feedback that we get from all of you in the audience. So I think I've drafted up a list to the higher ups for about 11, 12 episodes right now. But I think there's definitely room for more going forward. And, if you keep tuning in, we'll keep making them. So if we can pinky promise on that, we'll meet back here more often. So let's see here. Anything else in chat? Yeah. So again, more episodes to come, only a handful listed on there, but we will try our best to get them listed as far as possible in advance. We try not to schedule them out too far in advance in case any of that changes. We don't want your calendars to be out of date. Again, oh dear, that's me. Here's episode 1. You can learn a little bit about episode 2 and 3. Register here if you want those notifications. And without further ado, again, thank you so much for the interaction. I wish there was an easier way for all of you to chat with me here on the stream while we're doing this. Again, trying to make this very sort of a two-way conversation, right? This is not just Nick talking at all of you. This is us working together. But the interaction y'all have and the amount that you chat with me, it makes this a pleasure for me. So thank you again to all of you. I'm quite excited to be back for some of the future episodes as well. And I hope you enjoyed today, because I know I certainly did. We all learned some things, even me, and I do this all the time. So awesome. Well, OBS just told me I'm at the 2-hour mark, so I'm going to sign off, have some dinner, and get some rest. But thank you, everybody. Hope you enjoyed, and I'll see you all soon. Have a great night, evening, day, morning, wherever you are. And I'll see you back here at least on August 5th, and maybe sooner if you tune into the channel. All right, everyone. Bye. Take it easy.